This body of water is part of the headwaters of a river that flows from the eastern United States to the Atlantic Ocean. Like rivers all over the United States, this one has many functions and uses. It provides for recreation, it's appreciated for its scenic beauty, some parts of it are used by commercial fishermen and shrimpers. It serves as a habitat for numerous species of algae, insects, and fish. It also serves to carry wastewaters to the ocean, wastewaters from municipal sewage treatment, from urban runoff, non-point source wastewaters like agriculture, as well as point source wastewaters like those from manufacturing. This river has great value to those who use it, humans and lesser life forms, and it's protected primarily by state and federal laws that provide for regulation of discharges and maintenance of water quality.
So this is just a process of dislodging insects that are in the substrate and causing them to flow downstream into the net. The net is lifted so that the river water can run into it, and then it's rinsed a few times to get the silt and the bugs into the collection cup, which is at the end. And then the cup gets removed from the end of the net and gets dumped into a sample cup, sample bottle. We then get them back at our lab and we dry and weigh the samples to get a biomass, which also gives you a general sense of the productivity at a site.
Like many rivers in the United States that have multiple functions and uses, this one has manifold inputs from human activity. In the manufacturing category, about 3/4 of the distance from where I'm located to the ocean, this river receives a paper mill effluent. That effluent is strictly regulated by U.S. and state law, and these laws continue to change as the science that studies rivers and their life forms continues to change. About 20 years ago, some persons began to wonder what the effect a modern paper mill discharge might have on a water body like this. Not an immediate effect, not something you could go downstream and measure by catching some fish or measuring dissolved oxygen. That kind of effect was already taken care of by regulation, and that was part of the question: how much more regulation was needed? If scientists could look at the entire landscape effect of the paper mill discharge, from effects on the smallest component of the food web to the effect on the highest levels of aquatic life using the river, plus look at human activities and needs and how the discharge influences those, that could be a study of real value, applicable not just to the river studied, but in concept, almost universally valuable.
We're sampling for periphyton, which is algae on rocks. We're kind of looking for fist-sized rocks, although they're not always available. And we try to select a rock within 3 feet of the marker. The biomass is determined by measuring chlorophyll A, which is a green pigment in plants. And so we'll do that back at the lab. So we want to determine exactly how much algae is in this at the site and the different species, the relative abundance and species of algae at this site. And then we're going to filter a portion of it through these filters, and that will concentrate the algae on top of these filters. So algae is an important part of the food web, and it can tell us patterns about the macroinvertebrates and fish that are also at this site. And both macroinvertebrates, or aquatic bugs, and fish will feed off of algae.
The paper industry developed the long-term receiving water study because we were concerned that we didn't have the right type of information and data to demonstrate the long-term sustainability of the pulp and paper industry to the communities in which we operate and to the regulators which regulate us and to the general public. So if you look at the design of these studies, it's really quite interesting because it's a mix of both laboratory and field research, and some studies which are actually halfway between the laboratory and the field research, which are the mesocosm studies, which are also part of it.
Thus it came about that in the mid-1990s, representatives of the pulp and paper industry in the United States sought the advice of experts, respected scientists and engineers, as to how such a comprehensive study might be carried out. How many rivers would you study? How long would the study go on? How often would you collect samples? What would you study in the rivers? Who would manage and conduct the work? And importantly, how could the credibility and relevance of such a study be ensured?
Historically, one would take water quality samples, generally at a site upstream of the discharge, and one downstream, and you would determine whether or not there are differences in water quality downstream relative to your upstream site. The long-term receiving water study design undertakes an entire community approach, so we look at multiple biological endpoints, whereas most studies will only look at one or two. So we look at fish, macroinvertebrates, and algae, in addition to water quality and habitat measurements. We also take multiple replicates of each of these endpoints at each site every time we sample, so that we're able to account for variation that might occur within a site. The streams were selected to look at a number of different factors and to encompass a number of different factors so that they would be representative of mills across the U.S.
Of the 4 long-term receiving water study sites, or river segments, Codorus Creek in southeastern Pennsylvania is the most ecologically diverse, with a cold water upstream section following a dam and a warm water downstream segment supporting agriculture and urban functions. Codorus Creek is the most developed of all of the 4 rivers, bisecting York, Pennsylvania on its route from Lake Marburg to the Susquehanna River. The long-term receiving water study sampling sites occupy a 44-kilometer segment over the 77-kilometer river. At the discharge of biologically treated effluent, the bleached kraft mill on Codorus Creek represents 32% of the mean river flow. If there were going to be an effect of pulp mill effluents, this would be the place to find it. The mean in-stream concentration of pulp mill effluents in their receiving waters in the United States is in fact only 0.4%. The Leaf River in southeastern Mississippi is the largest undammed river in the United States. It's a warm water stream, and the study segment is 55 kilometers of this 290-kilometer long river, with an in-stream concentration of bleached kraft mill effluent of 2% at the discharge. The McKenzie River is a classic cold water trout stream in west central Oregon. The study length represents 31 kilometers of this 145-kilometer river, with an in-stream concentration of unbleached kraft effluent of 0.5%. The McKenzie is in fact a tributary of our largest long-term receiving water study water body, the Willamette River. The study segment on the Willamette represents about 50 kilometers of this approximately 300-kilometer river, with a mean in-stream concentration of bleached kraft mill effluent of 0.2%. The mean flows of these rivers range from about 2 cubic meters per second for diminutive Codorus Creek to nearly 300 cubic meters per second for the giant Willamette River.
So in the long-term receiving water study design, we encompass both spatial and temporal variation in how we've designed the study. Spatially, we look at multiple sites upstream of effluent discharge and downstream, typically 3 upstream and 3 downstream, although on one of our streams we have only 2 upstream sites and 4 downstream sites. Our study areas are quite large. Most study areas exceed greater than 25 river miles, so we're looking at a very broad spatial area. And because we're looking at multiple sites upstream and downstream of the discharge, we're able to disentangle potential effluent effects that we might see from changes that would occur naturally upstream and downstream. We also factor in differences that we might see temporally by sampling multiple times per year. We've sampled as many as 4 times per year for biota and 12 times per year for water quality. Typically, though, we look at water quality measurements 6 times a year and biota measurements twice per year.
The long-term receiving water study is a multifaceted study, which is focused not only on looking at the fish and the benthic macroinvertebrates and the algae in the receiving streams to which we discharge our effluents, but it is also focused on laboratory studies of those effluents, including both whole effluent toxicity testing and also measurements of various chemicals within the effluents. So we have collected over a dozen years worth of data which allow us to correlate the effects which we see in the biological responses, primarily in the laboratory, to actual chemical measurements of various components in the effluent. And then when we get to the field and we're able to measure the effects of those effluents on the field, we are able to link all 3 of these together: the chemical specific measurements, the bioassay measurements, as well as the actual measurements of the effects of the effluents on the fish, benthic macroinvertebrates, and the algae in the receiving streams.
Dr. John Rogers, a past president of the Society of Environmental Toxicology and Chemistry and a professor at Clemson University, is a member of the Long-Term Receiving Water Study Science Advisory Panel and an authority on the philosophy of stream studies. In discussing the question of whether to use natural substrates or artificial substrates for periphyton sampling, Dr. Rogers shared some philosophy on the 2 types of questions addressed in a stream study: considering the influence of a stressor and looking at upstream-downstream conditions. 1, is there a difference? And 2, if there is a difference, what does it mean?
Well, that's a seemingly simple question, that question related to natural substrates versus artificial substrates for periphyton and macroinvertebrates. But it's a very complicated question. It just depends on whether or not you're asking a question about context. If you're asking what's going on in a stream or a river, you need to use the substrate that's in that stream or river to ask that contextual question. If you're asking what can this stream or river support and there isn't any substrate, or you want to maintain the substrate and make sure the substrate upstream and downstream is uniform, then you might use an artificial substrate. But really, those are 2 different questions, and we had to have some discussion and sort through those questions as we designed the study. This was an opportunity for us to talk about the broader question. The broader question comes in when we're interested in if there's a difference, if we find a difference from upstream to downstream with the effluent in between, what does that difference mean? And that's that contextual question that I was talking about.
Macroinvertebrates constitute the middle tier of the food web in rivers. They are an important measure of the health of rivers and streams, and they're one of the fundamental components of assessment in the long-term receiving water study. NCASI is fortunate to have on its science advisory panel Dr. Wayne Minshall of Idaho State University, a world expert on macroinvertebrates and macroinvertebrate assessment metrics.
It might be worth my just saying what macroinvertebrates are first. They're mainly insects and crustaceans and other large non-vertebrate animals that can be seen with the unaided eye. So they're very representative of the ecosystem in general from the consumer point of view. Secondly, they constitute a substantial portion of that community, and they're important links in the food web. They're sensitive to environmental factors, a variety of natural environmental factors, but also to pollutants as well. And their sensitivity is at the level of weeks to years. So they make very good group of organisms to utilize when one is looking at long-term study over a number of years, a dozen years or 25 years or something of that sort.
When the long-term receiving water study was started here at the Spring Grove Mill, one of the first things that was done was the relative risk assessment, which was conducted by Dr. Wayne Landis and his students from Western Washington University. Dr. Landis and his students came to town and in conjunction with Gladfelter hosted a couple of town meetings where we invited regulators, citizens, and other interested parties to come and speak with Dr. Landis and his students and to explain what were the important features of Codorus Creek and the Codorus Creek watershed from their perspective.
Biological assessments of the environmental health of rivers and streams usually address three taxa groups: benthic algae or periphyton, macroinvertebrates, and fish. Because fish live longer than periphyton and macroinvertebrates, and they consume both of these groups, they are the group most likely to integrate adverse effects occurring within the food chain. Fish are also generally identified as the most prized component of the food web when human users of the water resource are asked to rank value. In the long-term receiving water study, enumeration of the kinds of fish present at the upstream and downstream sites is made at each major sampling event. This began as 4 times yearly, and fish are currently collected twice per year, in the spring and fall, on most study rivers. Fish are captured by several methods, including seining and backpack and boat electrofishing. The fish are not harmed in these collections, even when using electrofishing. Electrofishing is conducted so that the fish are momentarily stunned and removed from the water. Once the fish are identified to species and their length and weight are measured, they're returned to the water from where they were collected. Since the beginning of the study, over 50,000 fish have been collected, identified and measured, and released unharmed. So the long-term receiving water study not only measures whether there are differences in fish communities at upstream and downstream sites, but whether the fish that make up these communities are indicative of a healthy river condition. These measures provide multiple points of evidence for aquatic assessment. One of the great features of this lengthy and multifaceted study is that it allows observation of whether these patterns persist over time and whether changes are related to measured environmental conditions. If these patterns change, it can be determined if they change with some potential environmental stressor, such as an improvement in the quality of an effluent being discharged, or because of variation in environmental variables such as high flows during atypically rainy years, or other naturally occurring environmental factors. As Dr. Missimer mentioned, one of the interesting facets of the long-term receiving water study is that in addition to incorporating traditional biological assessments that really formed the core of the study, Dr. Wayne Landis of Western Washington University and his students also performed and authored scientific papers on a relative risk assessment study at each of the 4 study sites, each of the 4 rivers.
In Codorus Creek, we held meetings asking people, what do you care about? And it turns out that they care about things we call ecological services, which in the case of Codorus Creek is fisheries, recreation, water quality. It was very similar in the Willamette-McKenzie site that we'll talk about some more in just a minute, where it's fish, 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 water quality, water quantity, that's very important. In the Leaf River, again, it's what kind of fish, recreation, water availability, water quality. So that's something that we found common in each one of the sites. So We don't look just at the industry, we look at the urban areas around it, the agricultural areas around it, all the kinds of activities that happen within this particular area, so that when John Rogers or someone picks up a rock, counts the bugs, we have some idea of what the bugs are there doing, not just in the context of where the pulp and paper mill is, but also in context of the entire watershed. And so we're trying to understand the effects of all these different kinds of things on the bugs and on the fish. And we just can't add those up, because it's like adding apples and oranges and tangerines and dogs. So we try to put everything together in some kind of broader context. And the question comes from the people who live there, which is a little bit different than having it come from Washington, D.C. or Research Triangle Park.
So the study was undertaken, and right now, as I speak, it's in its 13th year of data collection. It has cost literally millions of dollars. It has resulted in presentations at scientific conferences and before regulators and the public. It studies 4 rivers at different locations about the United States. Each river study assesses chemical and biological samples over a gradient extending miles above and miles below the effluent discharge. It has resulted in publications in the peer-reviewed scientific literature. The study was designed as a mixture of field studies, assessing life in the rivers, and laboratory studies examining the effluents. The study is guided by a team of high-profile scientists, many from academia. This science advisory panel meets twice yearly with NCASI staff who conduct the studies and who present the resulting data. Total objectivity is assured by all involved, but to the layperson and scientist alike, the Science Advisory Panel represents true assurance of this objectivity.
We realized that we had to do something similar to what US EPA does and establish a Science Advisory Panel to advise the industry and NCASI about how the long-term receiving water study should be designed and conducted. And the Science Advisory Panel was established at the very beginning of the process for doing the long-term receiving water study. And it's been in existence the same number of years as the study itself and has advised NCASI from the very beginning.
Overall, the findings from the long-term receiving water study have shown that there are little to no changes in water quality downstream of the mill effluent relative to sites upstream. We also see little to no changes in fish community structure, macroinvertebrate communities, or in periphyton biomass. And finally, the long-term receiving water study and its results speak in several ways to the sustainability of the industry.
From the perspective of the original goal of this ongoing study, the results are pretty clear. Analyses of the first 9 years of data show that in these 4 representative rivers, first of all, land use is the most important factor affecting stream water quality and attainment of human-ascribed values, and secondly, understanding spatial and temporal variability is important in stream assessments, and the extensive upstream-downstream study area and duration of the study support this and serve as a template for other studies. Considering the effects of the pulp mill effluent discharges, for 3 of the 4 study sites, 3 of the 4 study rivers, there were no effects associated with the pulp mill effluent discharges with respect to periphyton, macroinvertebrates, or fish. On one stream, there were no effects on periphyton associated with the pulp mill effluent discharge. Considering macroinvertebrates, 6 metrics were studied, 5 of those showed no effects. 1 of them showed an effect. The water quality changed from very good to good. Considering the fish, 16 metrics were studied, 14 of these showed no effects, 2 of them showed an effect. Relative abundance changed in some fish groups. For all of the streams, there were no effluent-related changes in species type and relative abundance. Because of its considerable scope and duration, the long-term receiving water study is unique among stream studies. It was designed to address, with science-based surety, questions about the effects of a single type of industrial discharge, and it has done that and considerably more. It was undertaken with the best science mix of laboratory, mesocosm, and field studies, plus values-based risk assessments with oversight by internationally respected independent scientists. It's shown the importance of addressing long stretches of river upstream and downstream of a stressor in order to determine influences of all factors on the water quality and biology that might be attributed to the stressor. It's shown the importance of studying river health over seasons and years to understand the effects of natural temporal changes on the river biology. It's provided documentation of the significant influence of human land use on stream ecology. It's provided information on the variability of biological responses and how those are different from stream to stream. It's provided a template for use on other rivers and streams where effects of stressors need exploration. With its good news story about representative paper mill discharges, it's provided evidence of the sustainability of this key manufacturing sector in the United States. It's shared and continues to share results with scientists in a multitude of publications and at scientific meetings. The study continues, and additional analyses on an increasingly robust data set continue to inform the scientific community on important questions. On behalf of NCASI and the literally hundreds of people who have been directly and indirectly involved with this study, we want to thank you for watching this video, and we hope you found it informative. If you have questions about the long-term receiving water study, or if you would like to learn more about it, please contact NCASI. You can visit our website at www.ncasi.org or send email requests to info@ncasi.org.